For decades, we called it the ninth planet. Then we took it away. We demoted it, dismissed it, forgot about it. But when NASA's spacecraft finally reached Pluto after a 9-year journey, what it found stopped scientists cold. A heart. A living geological heart, blazing white across a world that should have been frozen and dead for 4 billion years. This is Pluto, and nothing about it is what we expected. To understand Pluto, you first have to understand where it lives. Pluto sits in the Kuiper belt, a vast frozen ring of icy worlds stretching billions of kilometers beyond Neptune. At that distance, the sun isn't the blazing ball of fire we see from Earth. From Pluto's surface, the sun looks like just the brightest star in a sky full of stars. It gives 1,000 times less heat than it gives us here. The temperature drops to -233 degrees Celsius. That is just 40 degrees above absolute zero, the coldest temperature physically possible in the universe. And yet, Pluto is alive. More alive than anyone imagined. On July 14, 2015, after traveling 5 billion kilometers over 9 years, NASA's New Horizons spacecraft had exactly 30 minutes at closest approach to Pluto. 30 minutes. That was all the time it had before flying past and continuing into deep space forever. In those 30 minutes, it photographed a world that rewrote every textbook. The first image that came back showed something impossible. On a world scientists thought would be uniformly gray and cratered, there was a vast, brilliant white heart-shaped region. Scientists named it Tombaugh Regio, after Clyde Tombaugh, the 24-year-old amateur astronomer who discovered Pluto in 1930. The left lobe of that heart, Sputnik Planitia, turned out to be the most extraordinary geological feature in the entire outer solar system. Sputnik Planitia is a nitrogen ice plain the size of Texas and Oklahoma combined. But it is not just a flat sheet of frozen gas. Look closely and you see something extraordinary. The surface is divided into enormous polygon shapes, each one 20 to 30 kilometers wide. And they are slowly, constantly moving. Deep beneath the surface, Pluto still generates internal heat from radioactive decay in its rocky core. That heat slowly warms the bottom of the nitrogen ice layer. The warm ice rises, the cool ice sinks. Over millions of years, these convection cells churn the surface constantly, endlessly. Pluto is geologically active. On a world 6 billion kilometers from the Sun. After New Horizons passed Pluto, it turned its cameras back. What it photographed became one of the most iconic images in the history of space exploration. Pluto, backlit by the Sun, surrounded by a perfect, brilliant blue halo. An atmosphere. Not thick like Earth's, Pluto's atmosphere is 100,000th the pressure of ours.
If you stood on the surface without a spacesuit, it would feel like standing in outer space. But it is there, and it is slowly escaping. Every year, Pluto loses a little more of its atmosphere to space. Here is the question nobody expected to be asking about Pluto. Could anything live there? In 2016, scientists analyzing New Horizons data proposed something extraordinary. The geological activity on Pluto, the heat still flowing from its core, suggested the possibility of a liquid water ocean beneath the surface. Not on the surface. Deep below, insulated by kilometers of ice, warmed by radioactive decay. A subsurface ocean. Similar to what we believe exists on Europa, on Enceladus, on Titan. If Pluto has liquid water, even cold, chemically rich water, the possibility of microbial life cannot be completely ruled out. We have not confirmed it. We need another mission, a Pluto orbiter, not a flyby, that can study this world over years, not minutes. That mission has not yet been launched. Somewhere, 6 billion kilometers away, Pluto is turning slowly in the dark, keeping its secrets, waiting for us to come back and ask better questions.